Hello students, in this video I'm going to give you the solution for all the problems in the worksheet that I have given you earlier, this worksheet on points of inflection. Now as I told you in person, please I strongly recommend that you solve those problems first and then you can watch this video to check whether you have done it correctly. Otherwise, if you just watch this video without solving the worksheet, it is not going to be of any help to you. Okay, so let us start with the first problem. Okay, now this is the graph of f of x equal to e power minus x squared. This is the first problem. Now they are given 5 points on the curve a, b, c, d and e, and the first question is, question A is, identify 2 points of inflection in this particular curve. Now we know that C is not a point of inflection because it is a point of maxima, and definitely now if you recall, for a point of inflection is a point where the concavity changes. So can you now look at the graph, students? Like, can you look at the graph where you feel the concavity changes? Now let us look at before B. Here it is concave up, and here it is concave down. Sorry, it's not very clear. So definitely B is a point of inflection. So one point is B and another point is D. So this is the answer. These two are the points of inflection, and definitely they are non-stationary point of inflection. It's very obvious. If you draw tangents at B and D, it won't be parallel to x-axis. So B and D are actually non-stationary points of inflection. Okay. Now the second question is, find f dash of x. So f dash of x is nothing but, let me differentiate this. So using the chain rule, e power minus x squared multiplied with minus 2x. So this is the second, is the B1. Now B2 is, they're saying show that f double dash of x equal to 4x squared minus 2 into e power minus x squared. So they have given this, they have given you the second derivative. You have to prove that. So how do you do? Again, quite simple. I have to differentiate this. So let me use the product rule. So f double dash of x is, I'll differentiate the first one, that is e power minus x squared into minus 2x. Then I'll keep the this function as it is, so minus 2x, plus I'll keep the first function e power minus x squared, and then I will differentiate the second one, which is minus 2. So I'll get 4x squared e power minus x squared minus 2 times e power minus x squared. So if you take this e power x squared common, you will get this answer, right? So again, it's very, very simple. Okay, now the C part is, find the x coordinates of each point of inflection. That means B and D are the points of inflection here. You need to find the x coordinates. Now as I told you earlier, these are non-stationary points of inflection, right? And so definitely the first derivative will not be 0, but the second derivative will be 0. So to find the x coordinates of B and D, you need to equate the second derivative to 0. So 4x squared minus 2 into e power minus x squared equal to 0, which implies 4x squared minus 2 equal to 0, because this will never be 0. Okay, this implies x squared equal to half. So x is plus or minus 1 by root 2. So these are the answers. These are the x coordinates of B and D. So the x coordinate of B is minus 1 by root 2 and the x coordinate of D is 1 by root 2. So the it is approximately equal to, it is plus or minus 0.707. Okay. Now the fourth question, that is D, use the second derivative to show that one of these points is a point of inflection. Okay, so either plus 0.707 or minus 707, you have to use the second derivative test. Now how do you use the second derivative test? what I told you earlier in one of my earlier videos, that before and after the point of inflection, the sign of the second derivative changes, right? So you need to show that. So what you need to do is draw a number line. Let me draw a number line here. So let me draw the number line. Okay. So let me take, let's say, this 0.707. Let me take the point D. Let's take a value more than 0.707. Let me take, let's say, 1. So f double dash of 1 is 4 minus 2 into e power minus 1, which is positive. So f double dash of x will be positive. Let me take a value less than 0.707. Let me take 0. So f double dash of 0 is 0 minus 2 into e power minus 0, which is negative, right? So f double dash of x is negative. So this is the answer. In fact, you have to mention that since the second derivative changes sign as it passes 0.707, before 0.707 the second derivative is negative, and after 0.707 the second derivative is positive. Okay, and you can also notice here that here this is concave up. I told you whenever there is concave up, second derivative will be positive, and this is concave down, and whenever there is concave down, second derivative will be negative. Second derivative will be negative. It will always be true, right? So this is the answer of the first problem. Okay, so this is the second problem, students. F of x equal to cos x by sin x. You have to prove that f dash of x is minus 1 by sin square x. So let me use the quotient rule. So f dash of x is denominator multiplied with the derivative of numerator. So derivative of cos x is minus sin x, minus numerator, that is cos x, multiplied with derivative of denominator. Here denominator is sin x and the derivative of sin x is cos x. So cos x whole divided by the square of the denominator, which is sin x the whole square. So we'll get minus sin square x minus cos square x by sin square x, which is nothing but minus 1 times sin square x plus cos square x by sin square x. Now we know that this is equal to 1. So minus 1 times 1 by sin square x. So minus 1 upon sin square x. So hence proved, right? So it's very, very simple problem. Now the second part is B is find f double dash of x. Okay, so let us find that. Okay, so let us find f double dash of x. So f double dash of x is, again let me use the quotient rule. So sin square x multiplied with the derivative of numerator, which is 0, minus numerator, which is minus 1, multiplied with derivative of denominator. Now derivative of sin square x is 2 sin x into cos x using the chain rule, divided by the square of the denominator, which is sin power 4x. So we'll get 2 sin x cos x by sin power 4x. Now in the problem it was mentioned that sin x is not equal to 0, so that means you can cancel sin x. You'll get 2 cos x by sin cubed x. Okay, so this is the second derivative. So let me write it down here. So the second derivative is 2 cos x by sin cubed x. Okay, now look at this table, students. They are given x, f dash of x and f double dash of x. Now the first question is find the values of p and q. Okay, now p is nothing but f dash of pi by 2, isn't it? P is f dash of pi by 2, so which is nothing but minus 1 by sine squared of pi by 2. We know that sine pi by 2 is 1, so minus 1 by 1 square equal to 1. So P is equal to 1. And you are also supposed to find Q. So Q is F double dash of pi by 2. So substitute pi by 2 in the second derivative. So 2 cos pi by 2 divided by sine cube pi by 2. So which means 2 times, we know that cos pi by 2 is 0, 2 times 0 by 1 cube, which is 0. So Q equal to 0. So the value of P is 1 and the value of Q is 0. Okay. Now, it is mentioned that you need to use the information from the table to explain why there is a point of inflection on the graph of F when where x equal to pi by 2. Okay. Now, we need to prove that this is a point of inflection. Okay. So, is it a point of inflection? Definitely. So if you recall, let us recall the point of inflection. There are two types of point of inflection. One is a stationary point of inflection, and the other one is a non-stationary point of inflection. Now, when will you call a point of inflection as a stationary point of inflection? It has to satisfy two conditions. The first one is the first derivative should be 0, and the second one is before and after that point, the first derivative has the same sign. And we also know that second derivative will be 0 at that point. Now let us look whether pi by 2 is a stationary point of inflection. Now here the first derivative at pi by 2 is not 0, it is 1. So definitely it is not a stationary point of inflection. So let us not worry about that. Okay. Now is it a non-stationary point of inflection then? Again, what are the three conditions that a point has to satisfy to be a non-stationary point of inflection? The first one is the first derivative should not be 0. Definitely it is not 0, it is 1. And the third condition is the second derivative has to be 0. Yeah, that is also true. And we also know that the first derivative has the same sign before and after 1. So here before and after 1 it has the same sign. So definitely it is a non-stationary point of inflection. And you can also mention that the second derivative before and after that point or have different sign. So that is another point that you should definitely mention. So the second derivative changes sign, okay, when it crosses that point. So these are the explanations. This is what you need to write to get full marks in that particular problem, right? Good. I hope you understood how to do this problem. Okay, this is the next problem, students. It's given that this function is defined only between -4 and 3, and it has a local maximum at 0, as you can see, a local maximum at 0, and local minima when x equal to -3 and -2. So you have local minima here. This is a points of local minima. Okay. Now the first question is, write down the x-intercepts of the graph of the derivative function. Okay. Now this is the original function, y equal to f of x. Okay. We know that there are three stationary points here. That means here f dash of 2 will be 0, isn't it? And because it is a stationary point, and f dash of 0 equal to 0, and f dash of -3 equal to 0. So there are three stationary points. The first question is, write down the x-intercepts of the graph of the derivative function f dash. So if I draw the graph of the derivative of the given function, then the question is, where will that particular graph, at which points will it cut the x-axis? So it is very easy. Wherever we have maxima or minima, those will be the x-intercepts of the derivative. So the answer for A is they are asking only x-intercepts, so -3, 0 and 2. So these are the points where the graph of the derivative function will cut the x-axis. Okay. Now the next point is, write down the points where f dash of x is positive. Now we know that f dash of x is positive when f of x is increasing. So look at the graph and identify where f of x is increasing. Very simple. Here f of x is increasing. So between minus 3 and 0, okay, open bracket, union, and also here between 2 and 3. So please don't write 2 to infinity because the function is defined only between minus 4 and 3. So in these two intervals the function is increasing, therefore f dash of x is positive. Now the C part is at point D on the graph of f, the x coordinate is minus 0.5. So they're saying that there is a point D whose x coordinate is minus 0.5. Okay. So y coordinate not given, of course. It's not needed. Y coordinate is not given. So you have to mention, explain why f double dash of x is less than 0 at D. The question is, there is a point D on the graph where the x coordinate is minus 0.5. You need to explain why f double dash of x is less than 0 at that point. Okay, so this is minus 1, right? This is minus 1. So D will be somewhere here. This is D. Okay, now we know that this part is concave down, and I have told you already, so whenever you have concave down, f double dash of x will be negative. So you can give that as a reason, or you can also say that here, that means in this part of the curve, the f dash of x is decreasing, right? So whenever you have concave down, f dash of x will be decreasing. So therefore f double dash of x is less than 0. So that can be another explanation that you can give. So I hope this is clear. Okay, this is the fourth problem, students. You can see the function is given 3 plus 20 divided by x squared minus 4, rational function. Now A, the point A, as you can see, is the y-intercept. So they're asking you to find the coordinates of A. Now to find the y-intercept, so that is the first part, to find the coordinates of A. And you know that to find the y-intercept, you need to substitute x as 0. So f of 0 is 3 plus 20 by 0 minus 4. That means 3 minus 5, which is minus 2. So the coordinates of A are 0 and minus 2, 0 comma minus 2. So these are the coordinates of A. So the second one is, you have to show that at A, that is B, at A, f dash of x is 0. You need to show that. Okay, how do you show that? Very simple. You need to find the first derivative. So let me find the first derivative. So f dash of x will be derivative of 3 is 0 plus this one. I'm going to use the quotient rule. So x squared minus 4 into 0 minus 20 into 2x by x squared minus 4 the whole square. So I will get minus 40x by x squared minus 4 the whole square. Okay, so at A I need to prove f dash of x is 0. That means at A we know that x is 0, so f dash of 0 is minus 40 into 0 by 0 minus 4 the whole square, so which is equal to 0, right? So it's very simple. At A, f dash of x is equal to 0. So that is also proved. Now the third part is, okay, now they have given the second derivative in the problem, f double dash of x equal to 40 times 3x square plus 4 divided by x square minus 4 the whole cube. Okay, now you have to justify that the graph of f has a local maximum at A. That is the next question. So that means at A, we have to prove that there is a local maximum. Now you might feel that it is quite obvious. You can see from the diagram there is a peak at A, so definitely there is a local maximum at A, but you have to prove it mathematically. So how do you do that? Okay, I hope you recall that we can find a local maximum value using the first derivative test or using a second derivative test. Now we already know the coordinates of A, right? And they have already given the second derivative. So let us check, let us substitute the value of x in the second derivative, okay, and check whether it is positive or negative. So f double dash of 0, f double dash of 0 is 40 times 0 plus 4 by 0 minus 4 the whole cube. So you'll get 160 by minus 64, which is negative. So we know that if the second derivative is negative, then you will get a maxima. So therefore A is a point of local maximum. Why? Because the second derivative is less than 0. Okay. Now the next question is, you have to explain why the graph of f does not have a point of inflection. Okay, you need to explain this particular graph. Why will it not have a point of inflection? Okay, again let us recall. For a point of inflection, I mean, you know that whether it is stationary or a non-stationary point of inflection, the second derivative has to be 0. So that is a necessary condition. Second derivative should always be 0. So let me find out whether second derivative is 0 for any point. So the second derivative is given here. Let me just take it. So let me equate the second derivative to 0. So I'll get 40 times 3x squared plus 4 by x squared minus 4 the whole cube equal to 0, which implies 3x squared plus 4 equal to 0, which is not possible, isn't it? Because 3x squared plus 4 will always be more than 0. So what it means is f double dash of x is not equal to 0 for any x. F double dash of x is not equal to 0 for any x. Whatever value you substitute for x, the second derivative will not become 0. So it means that there is no point of inflection. So this is the explanation, this is the answer. Fine. Now the next question is, describe the behavior of the graph of f for large values of x. Okay, so you have to describe the behavior of the graph of f for large. This means for large, I mean when x tends to plus infinity and minus infinity, what happens to f of x? We know that this has an asymptote. This has an horizontal asymptote. Now how do you find the horizontal asymptote? Very simple. You can see that as x tends to whether plus infinity or minus infinity, f of x, that is 3 plus 20 by x square minus 4 will tend to 3. Why is that? Because 20 by x square minus 4 will tend to 0, isn't it? Because just imagine if you increase the values of x, okay, so the denominator will become bigger and bigger and bigger and bigger and bigger. So definitely 20 by x square minus 4 will become will approach 0. So because of that, this f of x approaches 3. So what it means is there is an asymptote at 3. There is an asymptote at 3. So this is y equal to 3. This is y equal to 3. So this is 3. So as x becomes, sorry, let me just do the graph. This is the graph. So as x becomes bigger and bigger and bigger and bigger and bigger, f dash of x actually approaches 3. Here also as x becomes smaller and smaller and smaller and smaller, f dash of x approaches 3. So the answer is for C, the f of x approaches 3 for large values of modulus of x. Okay, and finally you have to find the range of f. Okay, I hope you recall how to find the range. Very simple. Take all points on x-axis where if we draw a horizontal line, if it touches the curve, then those points lie on the range. For example, this point lies on the range because if we draw a horizontal line, it touches at 2 places. This point, yes, definitely. This point, yes, but this point does not lie on the range because if you draw a horizontal line, it will not touch the f at all. So the range is nothing but less than this is less than -2. So minus infinity to -2 union. Okay. Now if you take any point here and draw a horizontal line, it will never touch the curve, isn't it? But if you take a point above 3, it will definitely touch the curve. So between 3 to infinity. So this is the range of f. Okay, so this is the fifth problem, students. F of x equal to 1 by 3x cubed plus 2x squared minus 5x. They are given the part of the graph here. Now they have mentioned that m is a maximum point and n is a point of inflection. So obviously it is a non-stationary point of inflection. The first question is find f dash of x. So f dash of x is very simple, 1 by 3 times 3x squared plus 4x minus 5, so which is nothing but x squared plus 4x minus 5. Okay, now the second question is find the x coordinate of m. Now it is quite obvious that m is a stationary point, so equate the first derivative to 0, that means x squared plus 4x minus 5 equal to 0, which will give me x equal to either minus 5 or plus 1. So definitely the x coordinate of m has to be negative, therefore the answer is minus 5. So the x coordinate of m is minus 5. And the next question is, C part is find the x coordinate of n. Now how do you find the x coordinate of n? Very simple. It is given that it is a point of inflection, and from the graph it is quite obvious that it is a non-stationary point. So definitely since it is a non-stationary point of inflection, the second derivative has to be 0. Yeah, of course, even for a stationary point of inflection also second derivative is 0, but here also for n the second derivative will be 0. So I'll find the second derivative, which is f double dash of x equal to, I'll differentiate this, which is 2x plus 4. So I'll equate that to 0. So 2x plus 4 equal to 0. So x equal to minus 2. So this is the answer. So n is in fact minus 2 comma some y, and m is minus 5 comma some, let's say this is y1, this is y2. Yeah. So x equal to minus 2 is the x coordinate of n. And the D part is the line L is the tangent to the curve at 3 comma 12. So find the equation of L in the form y equal to ax plus b. Very, very simple problem. So what you need to do is at 3 comma 12, slope of the tangent, right? Slope of the tangent is f dash of 3. Now I think we found f dash of x as x squared plus 4x minus 5. So we'll get f dash of 3 is 3 squared plus 4 into 3 minus 5. So we'll get 9 plus 12 minus 5, so which is 16. So the slope of the tangent is 16. So let the equation of tangent be y equal to 16x plus c. Now how do we find that c? Very simple. You have x equal to 3 and y equal to 12. So you'll get 12 equal to 16 into 3 plus c, which will give me c equal to 12 minus 48, which is minus 36. So therefore the equation of tangent is y equal to 16x minus 36. Yeah, so I hope this problem number 5 is quite easy. Okay, so this is the sixth problem. So the first question is they're given f dash of x is x minus 3 the whole cube. Find the second derivative. So f double dash of x is use the chain rule to 3 times x minus 3 whole squared into 1. So very simple. Now b part is find f dash of 3 and f double dash of 3. So f dash of 3 is 3 minus 3 the whole cube, which is 0. And f double dash of 3 is also 3 times 3 minus 3 the whole square equal to 0. So f dash of 3 is also 0 and f double dash of 3 is also 0. Okay. Now C is the point P on the graph of f has x coordinate 3. Explain why P is not a point of inflection. Now at 3 you can see that the first derivative is 0, second derivative is also 0. So we might think that it is actually, since the second derivative is 0 and the first derivative is also 0, it might be a point of inflection, a stationary point of inflection. But in the question they are given very clearly that it is not a point of inflection. You have to explain why. So definitely it means it has to be maybe a point of maxima or a point of minima, right? So let me check. How do you check it? Go to first derivative test. So draw the number line and mark 3 and take a value above 3. Let me take, let's say 4, and substitute in the first derivative. So f dash of 4 is 4 minus 3 the whole cube, which is 1, which is positive. So after 3 f dash of x will be positive. Let me take a value less than 3. Let me take, let's say 2. F dash of 2 is 2 minus 3 the whole cube, which is minus 1, which is less than 0. That means f dash of x is negative before 3. So this means the function is decreasing before 3. This means the function is increasing after 3. So that means the function will, the part of the function will decreasing, let's say this is 3, decreasing before 3 and then increasing after 3. So what you get there is a point of minima. So definitely 3 is not a point of inflection. Now, if 3 has to be a point of inflection, this f dash of x before and after 3 should have the same sign. But since they don't have the same sign, 3 is not a point of inflection. So this is what you have to write in your answer paper. Okay, so this is the 7th problem, students. The diagram below shows the part of the graph of the gradient function y equal to f dash of x. So this is y equal to f dash of x. So you need to sketch the graph of f double dash of x here. Okay, now since f dash of x is quadratic function, you can see that it is a parabola. So definitely f double dash of x will be a linear function. F dash of x is a quadratic. If we differentiate it, I'll get a linear function. Okay. One more thing is, here in the graph of f dash of x, q is a point of maxima. So what it means is, in the second derivative, the graph of the second derivative, the graph of the second derivative will cut x-axis at q. That means the q will be the x-intercept here. So definitely here the graph will cut the x-axis. Okay, you can see before q the function is increasing, right? So that means if f dash of x is increasing, then f double dash will be positive. So like this straight line, like this, and after q f dash of x is decreasing, therefore f double dash will be negative. So like this. So this is the graph of f double dash of x. Okay, now complete the table. Maximum point on f. Okay, you can see. Okay, now you have the graph of f dash of x, and you have, this is the graph of f double dash of x. Okay, now how can I find the maximum point on f? Now please look at the intercepts, x-intercepts in f dash of x, that is this p and q, p and r, sorry, p and r. This p and r will be the stationary points for f of x, isn't it? Right? P and r will be the stationary points in f of x. So let me observe let me take the point p. Let me take p. Let me take p. Okay. Now you can see before p, f dash of x is negative here. So before p, when x is less than p, f dash of x is negative. That means f of x is decreasing, right? And when x is more than p, that means here, this part, x is more than p, f dash of x is positive. F dash of x is positive, which means f of x is increasing. So what it means is, if I draw a graph here, let's say, I don't know, let's say p is here. Yeah, of course p is here. P is here. Then before p, f of x is decreasing, so it will look like this. So as you can see, p is a point of local minima, but I need the maximum point. Okay, let me take r now. So let me take r. When x is less than r, I'm taking r. When x is less than r, that means here, this part, f dash of x is positive. So f dash of x is positive. That means f of x is increasing. When x is more than r, that means here, when x is more than r, f dash of x is negative. That means f of x is decreasing. It means if r is here, before r the function is increasing, and after r the function is decreasing. So this here. So definitely the answer is r. So the maximum point on f, only the x coordinate you would write. So the answer is r. Okay. The next question is, find the inflection point on f. Okay. We know that here, if you look at again, there are 2 points of inflection, stationary and non-stationary points of inflection. Okay, let me take q here. We can see, I know it's this table is complete. Let me erase this. Now you see here that f dash of q is 0, isn't it, students? F dash of q is 0, because if we draw a tangent here, it will be parallel to x-axis, and f double dash of q is also 0 here. F double dash of q is also 0. So definitely there is a case of that q can be a point of inflection. Now for q to be a point of inflection, the sign of the first derivative should be same before and after q. Now that is true here, isn't it? When x is less than q, f dash of x is positive because the curve lies above x-axis, and when x is more than q, again f dash of x is positive. Therefore the answer is q. Okay, the answer, the first, justify your answer for part B2. That means, why do you say that q is a point of inflection? So you can mention that before and after q, f dash of x is positive. Right? How do you know that f dash of x is positive? So let me draw the figure once more. Okay, now you can see in the graph, before q, that is here, f dash of x is positive, because this is the positive side of f of x, f dash of x, and this is negative f dash of x. And after q also, f dash of x is positive because it lies above x-axis. So that is why we have q as the point of inflection. Okay, this is the 8th problem, students. It is given f of x equal to e power x sin x, where x is in radians. This is very, very important. Please remember, x is in radians. Part of the curve of f is shown below. Now they are given that the point A is a point of inflection, point B is a point of maxima, local maximum, and the point C is the curve intersects the x-axis at the point C. The first question is, write down the x-coordinate of the point C. Okay, now how do you find that? Very simple. To find the x-coordinate of point C, which is basically the x-intercept, we need to substitute f of x as 0. So e power x sin x equal to 0. Now we know that e power x can never be 0, which implies sin x equal to 0. Now we know that sin x is 0 for 0, 180, 360 like that, but definitely c has to be 180. So x has to be pi. Instead of writing 180 degrees, it is better to write x as pi, even though you might get the marks, but sometimes they might actually direct mark for that. Because since it is mentioned that x is in radians, it is better that you write the answers also in radians. So x is equal to pi. Okay. Now B, first part, find f dash of x. F dash of x, we'll use the product rule. I'll differentiate the first one, which is e power x. I'll keep the second one as it is, plus I'll keep the first one, I'll differentiate the second one, which is cos x. So basically e power x times sin x plus cos x. So this is the first derivative. Now the second part is, write down f dash of x at the point B. That means, what is the value of f dash of x at B? Now it's very simple. Since B is a point of local maxima, and we can see that if we draw a tangent at that point, it will be parallel to x-axis. So f dash x equal to 0 at B. So this is the answer. Now C part is, show that f double dash of x is 2 e power x cos x. Okay, that means I have to differentiate f dash of x. So what I'll do is, I have to differentiate this. So f double dash of x is, I'll keep the first one as it is, that is e power x, and I'll differentiate the first one, which is e power x, and I'll keep the second function as it is, so sin x plus cos x, plus, now I'll keep the first function, now I'll differentiate the second one. Derivative of sin x is cos x, and derivative of cos x is minus sin x. Okay, so this is f double dash of x. So if you open the bracket, I'll get e power x sin x plus e power x cos x plus e power x cos x minus e power x sin x. So you can see this and this will get cancelled. So you'll get 2 e power x cos x. So that is f double dash of x. So hence proved. Okay. Now D, the next question is D1. What is, write down the value of f double dash of x at A. F double dash of x at A, where A is the point of inflection. Now we know that the second derivative will be 0 at any point of inflection. So f double dash of x equal to 0 at A. So that is the answer. Now the second part is, hence calculate the value of A. So that means 2 e power x cos x equal to 0. Again, which means that e power x cannot be 0, so cos x equal to 0, which means that x equal to, so x equal to pi by 2. Okay, so x is pi by 2. Now they ask you to find the coordinates of A, so you need to find the y coordinate also. So y coordinate is, y is, substitute pi by 2 in the function, so e power pi by 2 times sin pi by 2. We know the sin pi by 2 is 1, so e power pi by 2 is the y coordinate. So the coordinates of A are pi by 2 comma e power pi by 2. Of course, you can also use the calculator and find the exact answer, I mean approximate answer. Fine. Okay. Ninth problem, I'm skipping it, but anyhow, let me tell you, give you some clues. If you look at the table, they're given you a table and then you're supposed to sketch the curve. It has a stationary point which is 0, because you can see that f dash of 0 is 0, isn't it? Okay. And double dash of 0 is positive. So that means 0 is a point of minima. Of course, you can also see that before 0, f dash is negative, and after 0, that is when x is between 0 and 1, after 0, f dash of x is positive. So basically it means 0 is a point of minima and the minimum value is -1. You can see that under f of x next to 0 it is given -1, so the minimum value is -1. So 0 comma -1 is a point on the graph. Okay, so that is one thing that you need to note. So before 0 the function is decreasing, after 0 comma 1, after 0 the function is increasing. That is one thing. And the second thing is you can see there is a non-stationary point of inflection which is actually 1. You can see that before at 1 the first derivative is positive, so it is not equal to 0, but the second derivative is 0. At 1 f double dash of x is 0, so the second derivative is 0. Before and after 1 the first derivative remains the same, I mean has the same sign. So before and after 1, first derivative has the same sign, so it is a non-stationary point of inflection. So again the 1 comma 2, f of 1 is 2, so 1 comma 2 is again another point on the curve. Now you can see that before 1, that is between 0 and 1, f double dash of x is positive. It means you will have a concave upwards type of curve. Before 1 you will have a concave upward type of curve. After 1, that is between 1 and 2, the second derivative is negative. That means you will have a curve which looks like concave down. Okay, because whenever second derivative is positive you will have concave up, whenever the second derivative is negative you will have concave down. So use these points to sketch the graph, students. Okay, let me go to the 10th problem now. Okay, this is the problem number 10. They will give a graph or part of a graph. Now in the table you need to mention whether f dash of x is positive, negative or 0 at a, b and e. Okay, it is mentioned that b is a minimum point and d is a maximum point. Okay, now f dash of a, you can see that it is part of the decreasing curve, so that means f dash of a has to be less than 0. Okay, now f dash of b, since b is a minimum point, so f dash of b is equal to 0. And again f dash of e is again a part of a decreasing curve, because f of x is decreasing there, so e is again less than 0. So this is done. Now again, that is the next table is, what about f double dash of x? What about the behavior of f double dash of x? So we have f double dash of x here. We have a, c and e. Now here you can see that a is part of the curve which is concave down, so f double dash of a has to be positive, and c is also same, part of concave concave up. A is a part of the curve which is concave up, so positive. C is also part of the curve which is concave up, so positive. Now E is a part of, this is concave down, so it is less than 0. Okay students, I'm stopping it here. I know that there are 3 more problems, but due to lack of time I am not going to solve those three problems. Of course, we shall discuss that in the class. Yeah. Thanks for watching this video.